Let's review stoichiometry. Several brands of antacid tablets use aluminum hydroxide to neutralize excess acid. Our stomach acid is mostly hydrochloric acid. What quantity of hydrochloric acid in grams can a tablet with 0.750 grams of aluminum hydroxide consume? That's our first question. The second question is, what quantity of water is produced? So let's do the first one. We have one given thing known to us, which is the mass of aluminum hydroxide. So we're going to take 0.750 grams of aluminum hydroxide. When you're doing this on your own, I do recommend you write out the chemical, but we have colors here and it saves us time and space. So I'm going to go from grams of aluminum hydroxide to moles of aluminum hydroxide. The molar mass is easy to calculate, but it is given to us. So 1 mole of aluminum hydroxide has a mass of 78.01 grams. When you're doing stoichiometry, pause and cancel out your units. That's what I recommend. That way we can see that we currently got rid of grams of aluminum hydroxide and we are moving into moles. Then I'm going to go from moles of aluminum hydroxide to pause and think, what do I do next? What units do I put down and for which chemical? For the first question, we need to determine the mass of hydrochloric acid. So we're going to go from moles of aluminum hydroxide to moles of hydrochloric acid. What do we do with these blanks? We use the balanced equation. We have a big 3 in front of the hydrochloric acid, and there is an invisible 1 as the molar coefficient for aluminum hydroxide. So we're going to put a 1 here. We're going to cancel out moles, top and bottom. And we've done a little bit of stoichiometry. We've converted grams of aluminum hydroxide into moles of hydrochloric acid, but notice it does say we want the grams, we want the mass of hydrochloric acid, so we do have to go one more step. Always read carefully and see which quantity do they want and for which chemical. So we're going to go another step, putting moles of hydrochloric acid in the denominator and grams of hydrochloric acid in the numerator. We're going to use the molar mass. Always use the molar mass when you see grams over moles or moles over grams. When you see moles and grams on opposite sides of the fraction bar, that means that you're using a conversion factor that is specifically the molar mass. And that does depend on the chemical. The molar mass for hydrochloric acid is calculated to be 36.46 grams. And cancel out your units. Moles are gone, grams are not. And now we are going to get an answer that is going to make some sense. It's going to be about 1.05 grams of hydrochloric acid. And that's our answer. That's how you do the stoichiometry for the first part of the problem. Now we got to do the second part of the problem. We're producing water as well. So there's two products here. We are producing aluminum chloride and we're producing water. So we're going to start off with the same thing we already started off with. We still have the same amount of active ingredient, 0.750 grams. And we're going to go from grams to moles. Same thing, we're still got to convert from grams to moles for the aluminum hydroxide. Same molar mass. So we can still just cancel that out top and bottom. And keeping going with this, we're going to go from moles of aluminum hydroxide to moles of water now. I'm color coding water with blue. So now we need a mole-to-mole ratio, not of aluminum hydroxide and hydrochloric acid, but of aluminum hydroxide and water. So we're going to still have the same 1 for the denominator because we're still talking about the molar coefficient for aluminum hydroxide down there. However, now we want the molar coefficient for water, which just happens to also be at 3, just like it was for hydrochloric acid. And we are going to continue with our math here. Always pause and think, what can I cancel out? So moles are gone here and here. We want moles of water to be gone. So we're going to put moles of water in the denominator, grams of water in the numerator, and we're going to use the molar mass for water, which is about 18.02 grams for every 1 mole. That's going to cancel, and we're going to get an answer that is about 0.520 grams of H2O. So that's a good review of stoichiometry, but these happen to be mass to mass or gram to gram conversions, but just remember that you could have been given Avogadro's number, or you might have used Avogadro's number if you were asked for it or had to be given number of particles. And there are other ways that stoichiometry questions can appear. We happen to have gone from grams to grams, but sometimes you have to stop at moles, sometimes you're given moles. Just read the problem carefully and cancel out your units.